In this video, we're going to look at rationalising the denominator of fractions containing algebraic surds. Now, you should have come across rationalising denominators with numerical surds back in topic N8b, and we're going to be using the same skills in this video. Remember what rationalising denominators means. It means eliminating any surds from the denominators of fractions. Here are a couple of quick recap questions for you. Pause the video and have a go at these. For question 1, the answer was simply 3. If you've got the square root of something multiplied by the square root of the same thing, then your answer is that thing. If you're a bit confused, just think of something like the square root of 25. If you multiply the square root of 25 by the square root of 25, that's really just 5 times 5, which is 25. Moving on to question 2, we want to rationalise the denominator of 13 over root 3. And from topic N8b, you should remember that we can do this by multiplying the denominator by the square root of 3. And to keep this fraction equivalent, we need to multiply the numerator by the square root of 3. And that will give us 13 root 3 over 3. From the first question, we know that root 3 times root 3 just gives us 3. Okay, let's get into the examples for this video. Let's look at the first one. We have 13 over root a. The denominator contains this square root here. To rationalise this denominator, you can multiply by the square root of a. Now, to keep the fraction equivalent, you'll have to do the same thing to the numerator. So we're going to multiply that by the square root of a. And the equivalent fraction that we get will then be 13 root a as our numerator, and the denominator will be the square root of a times the square root of a, which is just a. And there we have our fraction with the denominator rationalised. Moving on to the second example here, the simplest way to rationalise the denominator in this case is to multiply the denominator and the numerator by the square root of y. You could, if you wanted to, multiply the numerator and denominator by 5 root y, but you don't need to. It's simpler just to multiply them both by root y. Pause the video and complete this question. Here's what you should have found. For the numerator, we have x multiplied by root y, which is simply x root y. And for the denominator, we have 5 root y multiplied by root y. Now that's 5 times root y, don't forget the invisible multiplication sign in there, multiplied by root y again. Now multiplying those root y's just gives us y, so we have 5y. And there's our answer. Let's look at this next question. We have root t plus 1 over root 3t. To rationalise this denominator, we can multiply it by root 3t. To keep the fraction equivalent, we'll need to multiply this numerator by root 3t. Now, if we work out the denominator here, we simply have root 3t times root 3t, which is just 3t. Now, for the numerator, it's important to realise that the root t plus 1 is effectively in brackets. We want to multiply all of this by root 3t. Doing this, we simply get root 3t multiplied by root t plus 1. We've simply got root 3t multiplied by root t plus 1. Now, we can expand this numerator if we want to, so let's give that a go. We have root 3t multiplied by root t plus root 3t multiplied by 1. Let's start with that first bit. Root 3t multiplied by root t. Well, this root 3t here is really root 3 multiplied by root t, and then if we multiply that by root t again, we get root 3 multiplied by t. Notice that this t is no longer under the square root. And then remember we need to add root 3t multiplied by 1, which is just root 3t. So there's the numerator, and the denominator is simply 3t, as we've seen. Let's move on to the final example. Pause the video and have a go at this one for yourself. Here's what I would do. I would multiply the numerator and the denominator by root q. This gives us a denominator of 5 times root q, which is 5q. Now, our numerator will be 1 plus root q multiplied by root q. It doesn't matter which way round I multiply two quantities, so that is the same as root q multiplied by 1 plus root q. Now, we could either leave it at that, or we can expand the numerator out to give us root q plus q, and our denominator will still be 5q.